Hello everyone, welcome back to another video in the LLMs related playlist. In this video, we are going to see about how to create an end-to-end RAG architecture which can be run in production level from data ingestion till monitoring the RAG architecture at real time. For this, the first step for us would be to understand the architecture and then we'll move on to the code. The software architecture will look like here something like this. The orchestration framework will be Langchain, or else you can prefer Llama Index, but right now I prefer Langchain because it is much easier to use. An orchestration framework is a framework which will bring all the components together, and that will be the lowermost layer of the architecture. This orchestration framework is very important because this is gonna be the heart of the architecture, and for that we have chosen Langchain. When we come on to the RAG architecture, there are two main components which are going to be involved as the steps of RAG. The first one is going to be the retrieval process, and then the another one is going to be based on the retrieved data generating the output. So for this, in retrieval, we are going to use the OpenAI embeddings, and for vector store, we are going to use Pinecone. Why we are going to use these, I'll let you know in a bit, but right now just remember that for retrieval, we are going to use OpenAI embeddings, and for vector store, we are going to use Pinecone. And for generation, we are going to run Llama 3 on Groq Inference. So that is going to be our generation side, and this is going to be on our retrieval side. Is that all we require? No. When we are going on to production level architecture, it is very important that there is a control over the input as well as output if required. But while input, it is very much important that you have a control of what you are providing as input to your LLMs. And it is very important also that you need to monitor your LLM output, and then probably at the end, you can also add a layer on top of this here where you can add a data flywheel. Okay. So based on this monitoring, you can build a data set, which also I'll say at the end of this video of how you can build a data set based on this monitoring, whatever you have done till now, and how you can train your LLM based on that. We'll see about that at the end of the videos as well. Okay, but it is very important for you to monitor your LLM's output so that you can change its behavior whenever it's needed. But this is the component which is required for you to build an end-to-end RAG architecture. This will be the software architecture. All right. So now let's see how an RAG architecture works, and then we'll see how to build via a code. So now here we have the RAG flowchart where this is how the flow would be application. First, we'll be getting the URL and we'll be loading that. But in your application, based on your use case, if it is a PDF or if it is a CSV or if it is a text document, you can change your loader. But right now I'm just using web. All right. Then we have the text splitter for chunking, because if there is a data of around 10,000 characters, we'll be splitting it as 1,000, something like that. Okay. And those split chunks are known as documents, and those documents would be added into the Pinecone vector store by computing the OpenAI embeddings for it, and then it would be stored. So once that is done, we'll get the input from the user on the user query, whatever they want. But usually in our RAG architecture, this is not something we do. Here we'll do an input check with the help of guardrails to make sure that it follows some guidelines. So why do we need these guardrails? It is to make sure that the question falls under the scope of the questions you want to answer. For example, there might be questions which might involve some words which should not be there in the question, and then you don't want to answer it. Or there might be some other things like falling out of scope of whatever you have. So for those questions, you can have guardrails, and it will protect from the question going on to the architecture for two things. One, avoiding any mistakes which might come, or two, it is waste of tokens, right? Because retrieval, generation, monitoring, these are all gonna cost us with a lot of tokens, and we can avoid that. So for that, we are adding a step known as input check. And by the way, you can also monitor the number of tokens you are using with the help of Langsmith itself, which we will see in the monitoring component. So once you have done your input check, the next step would be to retrieve with the help of retriever. Here the pinecone vector store itself will act as a retriever, but this is just a dense retriever. If you want, you can also add a sparse retriever in the form of BM25 retriever and ensemble it. These are all some advanced components of retrieval. If the use case demands it, you can try to use it. And if you want to know how to do that, let me know. I'll make a video on that probably. And for generation, next, once you retrieve the related whatever documents there are, you need to generate the answer with the help of generator component, which will be running LLM as Llama 3 on Inference Engine as Groq. So Llama 3 will be running on Groq. All right. So finally, for monitoring all of these processes, we'll have Langsmith, which will store the trace, and finally you will display your answer output in UI. So this is how the flowchart is, and now we'll see the code in detail. Here is the code for creating the RAG end-to-end architecture, and for this, in your .env file, you will need 4 important keys. One is your Langsmith API key, and then your Pinecone API key, your Groq API key, and your OpenAI API key. Because for embeddings, we are using OpenAI. For LLM, we are using Llama 3 running on Groq. And for vector store, we are using Pinecone. And for monitoring, we are using Langsmith. But why I have chosen these specific things, that is what we are going to see now. First, let's see about the vector store Pinecone. Okay, Pinecone vector store offers you a serverless index. All right, so let's see about that now. Here is the Pinecone's pricing, and if you are a starter, right, so they are providing up to 2 GB storage where you can store 1536 dimension vectors. So higher the dimension, higher the better the result it's gonna be at lot of situations. And OpenAI's embeddings, which is an API, again we'll see about that as well, also provide 1536 dimension vector. Okay, so here it is said that with this 2 GB storage you can store up to 300k embeddings. I think that is fine. Okay, and you can write 2 million units per month and you can read 1 million units per month, but you can have only one project. Okay, so indexes is nothing but how many databases you have. Okay, under that one project you are allowed to have 5 indexes, and namespaces is nothing but the user. Okay, you can use, you can have 100 user per index, which means 500 users can be used. All are for free. But if you go on to the standard section, again guys, this is not a paid promotion. I'll just let you know. When you're going for paid option, I think Pinecone is best. Okay, because of what they provide. All right. As a developer, you might not know in a lot of scenarios that, okay, this is what is gonna be my number of requests per month. Okay, so for that only they have provided this serverless option. If you know what is gonna be there prior, you can just choose pod based option, or else you should just use serverless, and that is what we'll use in this video. Okay, so for this, what you need to do is, here if you see in serverless indexes, for storage they are providing 5 million documents. You can just store 5 million documents up to 10 million vectors of 1536 dimension, and that will just cost around $21 per month. And if you can hit 1 million queries per month, which will cost you $83 per month, and you can upload 10 million vectors per month, which will cost you $70 per month. Okay, on a total it will cost you $170 per month. Okay, so that is what is said in this option of serverless index. And there are some other things also they have provided, but you can also see here. Okay, so for example, if you're going for serverless using Amazon Web Services, all right, so if you're choosing this region of US East, that is what is the cheapest. Europe is slightly costlier. Okay, and here is the pricing. And if you're going for pod-based index is a thing which you are thinking that, okay, in my 1 month I'll be just storing around 5 million vectors. Okay, if you know for sure that you're gonna store this much, that is when you're gonna choose pod-based index. Okay, so this is how you need to choose. And why I'm explaining all of these, because we are seeing a production level end-to-end architecture, and if you are going to use serverless, right, it is going to be pay per use, and you can scale it how much ever you want. Okay, so that is what even it is said here. See, for production applications at any scale. So that is our vector store, which is scaled at a lot of user level. Okay, if you want to put that way. Now for embedding, I'm using OpenAI's embeddings model because right now Groq isn't supporting an embedding model, and OpenAI is highly scalable. We all know that. With OpenAI embeddings, the best option would be small because it is providing a performance of around 63%, and large just provides 65%. Okay, but for $1, here you'll get 63,000 pages, and here you're getting just 10,000 pages. Okay, so if you are paying $1, you can just store 63,000 pages, assuming that each page has 800 tokens. So if you multiply that, and here also they'll have a pricing page. We'll see that as well now. OpenAI pricing. Okay, so if you see here in embeddings, they'll have it here. Okay, fine-tuning more embedding model. Here you can see for small, there is for 1 million token you can use for $0.02, which means you can store 50 million tokens. Okay, 50 million tokens for $1. Okay, just for $1 you can store 50 million tokens, and that is pretty huge, right? So that's why I chose OpenAI embeddings, though it is not the best open source model right now. I mean, or the model which you can use right now for your architecture, but this is the most scalable architecture which you can create right now. Okay, so for that we have chosen OpenAI, and for LLM we have used Groq because the pricing is also very less. I'll go into Groq. Okay, documentation, and here if you see, let's see here. Okay, Groq pricing. Here if you see, for Llama 3 8 billion, you get for 1 million tokens, you are gonna just give $0.05. Okay, and for all it is just cheaper than the original one, so that's why we are choosing here, and it is very fast, which means in your production architecture it is going to be fast, which means your outputs are going to be good as well as fast enough, right? So we have combined the best possible components, which is highly scalable, because now they are working on scalability, and for enterprises you can contact them specially. That's what they have said. Okay, and you can also use fine-tuned model, it seems. All right, so for enterprise also you can just contact the teams. So we are done with our LLM, which is highly scalable now, and it is fast enough, and you have your embeddings model. Again, OpenAI is so good. And finally we have the vector store also, which is highly scalable. Now we have created a highly scalable yet fast architecture. Okay, now to monitor all of these, we are going to have Langsmith. Okay, so Langsmith is a monitoring framework which is written by Langchain themselves, and that's why I chose Langchain as the orchestration framework, because with this it is said that once you monitor, right, you can add those to your data set, and your output, whatever you get from your model, can become your input for retraining the model. Okay, and there are a lot of other things which we'll see later once we see the code and the demo. Now let's see the code. Okay, so here we have the code. All right, so first we are importing all things which are needed. Web-based loader to load the web document and or web page by using Beautiful Soup. Okay, so for that we have BS4 also imported, and for splitting, like I said, we have character text splitter. For embeddings, OpenAI embeddings. To create a Pinecone index, we have Pinecone client created, and since we need to use serverless, we are using serverless spec. But if you want to use pod, you can also use pod spec, but we won't need it. Okay, but I have provided that option so that you can change it and make it work for your pods. Okay, and then we have Pinecone vector store because we need to work with Pinecone vector store. And Langchain, from Langchain we need to import hub so that we can get our prompt for RAG from Langchain itself, because there are good prompts which are defaultly written, and we are going to use one such prompt from there. And then we have chat Groq so that we can use our LLM, Groq LLM, and then runnable pass through, because this is nothing but it will just send the input from one to another. But when you go through this runnable pass through, right, it will help you to log it in Langsmith. Okay, so to parse the output however we want, we have the output parser as well to load the .env file and the whatever constant we have. So to first we need to find the .env file. For that we have find.env, and for loading that file we have load.env. And from Nemo guardrails we have the Rails config imported, and in Nemo guardrails they have provided an integration with Langchain, which is runnable Rails, and that can be integrated with a runnable pass-through. Okay, so these are the imports, and here you need to set some environment variables. The first variable would be setting up the Langchain tracing v2 to true, so that all the components are traced, whatever it is passed from one to another, right? And then we have the Langchain API key set along with the Langchain project name, whatever you want, you can give. I have kept it to end-to-end RAG new. Okay, and here also I'm providing a vector store index name, which is end-to-end RAG new again. And here I have the web-based loader. So to load the website based on the URL as a document, we need web-based loader. And for this, you'll be providing the website path. You can provide multiple paths as well, but right now I'm just providing single path. But you can provide multiple paths as well. Like I said, this is an end-to-end RAG architecture, which is highly scalable, right? So with that being said, you can provide multiple URLs as well. Similarly, you can provide multiple PDFs upon your choice. And for the beautiful soup, we are providing the argument stating that for parsing, you can use beautiful soup's strainer, where you will just consider the post content title and the headers alone, not the tags and all. Okay, that is how we are going to parse the HTML file, HTML page. And for embeddings, we are using OpenAI embeddings, and for LLM, we are using Groq, which is running Llama 370 billion. We have the recursive character text splitter, which has a chunk size of 2000 and an overlap of 100, which will split the document from 0 to 2000, and then 1900 to 3900, and then 3800 to 5800, retaining a context of 100 tokens in there. Okay. Here next we have the create pinecone index function, which will create the pinecone index. Okay, so for creating a pinecone index, first you need to create a client, pinecone client, for which you'll provide the API key. And then for serverless specification, like I said, you saw there, right? There are US servers and Europe servers. You can provide whatever you want there and what type of cloud you want, because they also provide GCP and Azure support, if I'm not wrong. You can also provide that, but right now I'm just providing AWS, and the region is US East 1. But we are also checking, because see, right now we are allowed only some indexes alone, right? So we are just making sure that at runtime there is only one index. So if there is an index of what I'm choosing here, for example, end-to-end RAG new, if that is there, I'll delete that index and I'll create a new index. That is what is there here. Okay, if it is there, I'll delete it and then I'll create it with the dimension of 1536, and the similarity is computed with the help of dot product, and what type of specification I want, serverless specification with this specification. Okay, so that is how you create your pinecone index. And once that is done, your index is ready, which means you can call the pinecone vector store with the index name, and you can provide the initialization with OpenAI embeddings along with the API key. Okay, which means your vector store is initialized, your text splitter, all are instances. Okay, your LLM instance is ready, your embedding instance is ready, your vector store instance is ready, your prompt template instance is ready, your guardrail instance template is ready. I'm just blabbering, no? Like all instances are ready. Simple. Your web loader is also ready. So all your instances are loaded in this init function. And then here there is this root function or the core function, which is QA, where I'll get two functions. Okay, the first one is query and then another one is vector store created. So we'll just think that, okay, see, for example, if I'm providing a website, to create a vector store, that is one time only it is required. After that, it is not required, right? So we'll check if the vector store is created, and if it is created, we won't compute the vector store. Okay, so that's why vector store created is given as pass. And for else, if the vector store is not there, we'll call the create retrieval chain function, which is here. Okay, so how is the create retrieval chain function ready? Actually, there can be a change which I'm gonna do now, right? So we'll call that here. What I'm going to do is I'm going to add a parameter known as vector store created here, so that if the vector store is created, else can be added here. Okay. So the idea is that if the vector store is created, I need not create the vector store again. Okay. So the vector store creation process happens with load docs in vector store chain. All right. So for that, first we'll load the documents from the loader. Okay, which we created there, web-based loader, and the document is splitted by using the character text splitter. And once the documents are ready, we'll add those into the vector store. Okay, by calling the add documents function, you need to provide the documents alone. Okay, so now with this, your vector store would be ready. Okay, and then you will need to create your RAG chain. Okay, so for this, you will provide your retriever and your question. Okay, question is got from the user, and that's what you are providing with the runnable pass through. Okay, and I need to add it here. Okay, when you call the invoke, that will go on to the pass through. All right, so here we'll make sure that the vector store is now retriever, and then the context is obtained from retriever, where you will pass it through the format docs function. So what it will do is, let's say you get around, we'll put it as 5 documents. Okay, so what it will do is the 5 documents will be retrieved, and all of those will be combined in this format. Okay, there will be 2 new lines, and then the first document will be there, then 2 new lines, the second document will be there. That is how the format docs will format your document, which will become your context, and then the question is got from the user. And both of these are provided to RAG prompt. Okay, this runnable pass-through is very nice, like following this LCEL. This is Langchain expression language, and with this you have this kind of control a bit. And for even more control, we can use LangGraph, which I'll say later, because I'm planning a course on that. We'll see about that later as well. Okay, in some another video, I'll make a video on LangGraph. But right now, we'll focus on this. Okay, so once your prompt is formatted, you're providing it to Groq LLM, and then your output is passed. Now you might wonder, Vasanth, where is the guardrail, right? Like I said, guardrail will be provided at the input level itself. We'll just check if the query is good. If the query is not good, we are not going to use that. Okay, so first we have the guardrails, and then we'll pass into the RAG chain. Okay, so that is how your retrieval chain is created, and then you invoke your query. Okay, so that is how you'll create your retriever. Okay, now since we know how the retriever is, or the RAG app is created, now we'll see the UI side. Okay, so you are importing the RAG class. Okay, and to load the RAG class, we have here. Okay, the load RAG pipeline will take a website URL, and you'll provide that to the RAG class, and that will create an instance of RAG pipeline. Since all of these are async processes, especially with guardrails and the vector store creation and all involved, there are a lot of async loops involved in there. To make sure that there is no error, we have this function. Okay, this is just a util function. All right, so here we have the other thing, which is the session state. Okay, first the session state will be click to set to false. Okay, so here we have the title and header that we are not going to consider. So first we'll get the URL, and the URL, once it is entered, we can just click enter to apply. Okay, and what we'll do is we'll load the RAG pipeline. Okay, so where is the load RAG pipeline? We'll see that. Okay, here it is. Yeah, we'll create the RAG pipeline instance, and once that is done, we'll set the click to true, and if the click is true, then only we'll get the question from the user. And with the question there, we'll call the QA function with the question along with the vector store created. Okay, so initially the vector store created would be false. Okay, because here if you see, the logic is such that if the vector store is created, we won't call the load docs into vector chain function. Okay, so initially it should be false, and then in the next step it should become true. Okay, so initially it's set to false, and here if you see, we'll return 2 things. One is the output along with true. Okay, and here what I did was, we'll get the another value as vs, and then we'll assign the true to vector store created. Okay, so once the vector store created gets this value, we'll write the output as well, and that is what is displayed. Now we'll see the application. Okay, so I'll put my image here. We'll ask it Streamlit run app.py. So for this, what I'm going to do is I'm going to take the latest document which is there in Wikipedia. Okay, so now let's do that. Here we have the application, and what I'm going to do is I'll go to Wikipedia, and what I'm going to do is let's take English so that the latest architecture is there. And here is the latest article which is on Mary Anning, and I'm going to take that. And here we have an article. Just getting architecture in my mouth. We are having a document on Mary Anning. And by the way, I didn't say about the rail config, because here if you see, this is how we will create the runnable rails, where first we'll get the rail config, whatever is the fence. Okay, so this guardrail is kind of a fence where after that you can't go. Okay, so for that you'll have a config folder in which there are two configs. Okay, the first is rails. Okay, that's how you'll need to start, and you can also provide it for output. Okay, for input I'm just providing in flows. You need to do the self-check input, and how to do the self-check input, that is what we give it in the prompts. Okay, in prompts for the task of self-check input, this is the content. Okay, your task is to check if it follows these, and I'm saying some rules here, especially it should not contain any harmful data, it should not impersonate someone, and so on and so forth. Okay, so finally what it will do is it will see, okay, should the user message be blocked or not. If it says yes, it will be blocked, the pipeline won't execute, and if it says no, then the pipeline will continue, and we'll check both of those. Okay, we'll try to get both kind of output from there. Okay, now let's go into the application. So for that, first what I'm going to do is let's ask this itself. Okay, I'll provide the URL. It's loading now. Okay, as you can see, the question now popped up, which wasn't the case before, which means it is ready. Okay, so now I'm going to ask who. Now we'll try to get a yes answer, which means the pipeline shouldn't execute. Okay, who the hell is, sorry for my vulgar language, who the hell is Mary Anning? Okay, we'll ask this, and I'm expecting the model to say I can't answer, something like that, but it is answering. Oh, okay. Let me put another question again. Yeah, you can see it has said who the hell is Mary. When I asked that, I'm sorry, I can't respond to that. Okay, now we give two questions, and in one we didn't get this answer, right? So what happened, we are going to see that now. Langsmith, if we go into the Langsmith and whatever project we created now, which is, if you remember, end-to-end RAG new. Okay, and in this, if you see, I've totally used 498 tokens and in 3 runs. Okay, total on a run, it is approximately taking 172 tokens. Okay, here if you see, for this question, it didn't take for some reason, but probably we can give correct prompt probably. But here if you see, when I asked who the hell is Mary, the AI said yes, and we didn't get an output, right? But here if you see, there are two things. Okay, once you get no, that is when your runnable sequence get executed, and here is how you get the output. Okay, but for example, if I ask impersonify yourself as Mary and tell me about yourself. But here you also see, right, why I asked this was, now if you can see here, it is added. All right, here I was explicitly providing a statement that should not ask about the bot to impersonate someone. I told it to impersonate Mary, and it said okay, I'm not gonna allow this. Okay, so this is how you can provide lot of fins, like saying, okay, this is not something you can do. Again, here we are using the LLM, but see here, now the token is just 676. Okay, previously it was 472, now it's 676. If we divide it by 4, it is 173. That is fine, but the token is going to be high only with this runnable sequence, because you are going to use a lot of tokens in here. Okay, and this is how it goes. Okay, once you provide the input, it goes into the retriever. Okay, the retriever. So what the retriever does is, here you should get something. Just give me a minute. And yeah, here if you see, the content is there. Okay, and here I'm asking who the hell is Mary Anning. Okay, and the chat Groq is then answering with some answer in here. Okay, that's how you can see, okay, what is going on in behind. Since I didn't say I need to parse it in an explicit manner, it isn't parsing my output, But if you want, you can also do that as well. Okay. And here, if you see, you can add this to a data set. Okay. This will create a data set. Now, if I want to do that, what I need to do is in data sets, I need to click a new data set. Okay. What I'm going to do is dummy. Okay. I'm going to create dummy. And this is going to be an LLM data set. Okay. So let's see here. If you see, we have the data set, right? So what you need to do is go to your project, whatever we did now, go to end-to-end RAG new, go to the runnable sequence, add to data set, and here we are going to choose why new data set. Okay. Here also you can create it seems. What I'm going to do is I'm just going to give like this, and now this is going to be stored in this data set. Okay. If I go to this data set now, okay, ASDAD, and we have the input and output, right? Which means you can train, right? So for example, if I'm going to load a Wikipedia, all right, and then if I give 10 questions with each Wikipedia URL, and probably you can also generate that with the help of LLMs itself, you have a data set for yourself, and that is how you can create synthetic data. And I am going to create a specific video for this itself, and we'll see that. Okay. But like I said, this is how you create an end-to-end RAG for production. Now you can see you can monitor your outputs, you have your monitoring of the tokens, you can control what kind of output should be there, what kind of output should not be there. Same goes for input. Everything which is to be considered in production, even including scalability, is considered in this creation of architecture. So yeah, guys, I hope you all like this video because this is the most requested video for me. I hope you all like this video. If you all like this video, please hit the like button. It is just free for you, but it recommends me to a lot of users. Right now, my YouTube is not so going so good. So please recommend to your friends as well, and as well to your community. So let me know your thoughts in the comment section of what we need to do next. I have a very big surprise announcement coming up. Very soon the announcement will be done. I'll see you all in the next video, guys. Until then, cheers.